A very good afternoon to you all. I'm Pahul Sachdeva from XII-C, and today, as a part of Section D of Periodic Test 1, I will be taking up Calculus for Reciprocal Teaching. So far, out of the two course books, we have studied Chapter 5, Chapter 6, and Chapter 7. We have studied some limits, some derivatives, and some integrals. Today, I will be revising the important concepts and formulas of these three chapters through flowcharts. Even though PT1 syllabus includes only 2 chapters, Chapter 5 seems fairly important. And considering our brilliance in 11th grade, we will begin with the basic concept of limits that we were introduced to last year in 11th grade. Limits. Note that the encircled value on the screen is a function y equals to 1 by x. The limit on the screen can be reworded as a question. As x approaches infinity, y reaches what value? So when we look at the graph, we can clearly see that as x increases, y approaches 0. Now note that y doesn't reach 0, it approaches 0. This is the super basic rundown of what we did in 11th. Of course, along with the evaluation of limits with actual values. Moving on to Chapter 5, Continuity and Differentiability, which is a continuation of what we just revised. We find that with the updated syllabus, the mean value theorems and hence exercise 5.8 and question 19 of miscellaneous exercise have been removed. This leaves us with continuity. A real valued function is continuous at a point in its domain if the limit of the function at that point equals to the value of the function at that point. Further, we use the chain rule formula for computing the derivative of the composition of 2 or more functions. Some standard derivatives obtained within their appropriate domains are as follows. Another method used to differentiate certain functions is the logarithmic differentiation. Here, both fx and ux must be positive. Chapter 6. Applications of derivatives. Derivatives can be used to determine the rate of change of quantities, to find equations of tangent and normal to a curve, and to locate the maxima and minima. With the topics rate of change and approximation removed, exercise 6.1 and 6.4 and question 13 and question 19 are no longer a part of the syllabus. Bringing us to the application of differentiation, where we use it to find out whether a function is increasing or decreasing or none. Let I be an interval contained in the domain of a real valued function f, then the function's nature can be analytically defined as displayed. These functions can further be defined as strictly increasing functions, strictly decreasing functions, and neither of the both. In the next application, differentiation is used to find the equation of the tangent line and the normal line to a curve at a given point. Chapter 7. Integrals, or in other words, antiderivatives. To perform integration, we use certain standard integrals of the fundamental functions. There are 3 major methods of integration. Let me explain the first method through an example. To solve the given function, we use the standard derivative formula of tan inverse x to substitute it with t, so that dx by 1 by x square equals to dt. Upon reaching minus cos t plus c, we then restore the true value of t as tan inverse x to obtain the answer. The next method requires a special reference table. An example of integration by partial fractions is as follows. The question is a proper rational function. Therefore, we use the reference table to simplify the integrand and then integrate it to find the answer. The integration by parts method is often useful in integrating products of functions and is preferred because it results in less complicated solutions. Definite integrals are those with unique values. The chapter comes to an end with these 7 properties that help us in evaluating them. I hope this video helped in revising for our upcoming exam and in some ways for the pre-periodic test. Please feel free to interject with your questions.
Pahul, can you give an example of logarithm differentiation that you had mentioned in the first flowchart?
Yeah, okay. So here first though we will consider any normal question like this one where we have to differentiate ax with respect to x, and here a is a positive constant. So here we are going to use the formula that we have for solving logarithmic differentiation, wherein we are going to let y equals to ax, and because of this we will get the statement that log y equals to x log a. And after this step we just have to differentiate both sides with respect to x, and this will give us 1 by y dy by dx, and it equals to log a, and then dy by dx equals to y log a, and this will eventually give us the answer that d by dx, a raised to the power x equals to a raised to the power x log a.
Can you show how definite integrals can be solved by substitution method and not just the properties?
Yeah, for that also we will just consider a question like this one. This is from the NCERT only, and here first we are going to consider this integral without limits, and we will just substitute this term with t, and then after integrating this specific term, we will I will integrate it without mentioning the constant, and then whatever is obtained after solving this, we are going to resubstitute it in the original integral, and then we are going to find the actual value, the answer, along with the limits. So it's going to look something like this, and then when we solve it the answer is probably going to come.